I've been waiting a long damn time for this video. This is my vacuum turbine, or as we'll refer to it, our damn turbine. It is a vortex or siphon turbine. This is our inlet right here, and right down here is actually where we'll be testing on this little ledge in the overflow. So the inlet will drop into our reservoir or our intake. This will sit right on that board, and then on this side we have a 5-foot outlet pipe. So the difference between the intake and the outlet is about 4.5 foot. It's all 3-inch PVC pipe, and coming across we have a simple little motor mount here, the 250 watt DC brush motor that we always use. Coming across we have, right now it's connected to the 20-tooth pulley, giving us a 1-to-1 ratio, but I have them all stacked on here, so in the future test all we have to do is loosen and slide these up. And coming across, you can see this is a brace just to keep this rod centered and keep it from rotating and bouncing around. If you want to see a more in-depth breakdown of how I made this turbine, check out my separate video posted in the description below. It ended up being a pretty long description video, so I figured I'd just make a separate one. So coming across, this is how we will initiate our vacuum off our Ryobi vacuum. So this will come to a pipe with a shut off on the top and the bottom. Ideally, we want the bottom one shut off when it's operating, but this way, for convenience, we can have one at the top. So let's get it in there, do our standard testing, and we'll figure it out. Normally, we do our testing in the order of voltage with no load applied, so no heaters connected. This will give us a voltage only reading, and then it won't provide resistance on the motor. Then we'll connect 2 of the heaters, or maybe 1, depending on how fast it's spinning in the system or our voltage in the initial test. We'll get our power reading, and we'll go from there. If we can jump it up and get some more power, or just connect more heaters, we'll do that. So let's go over there. I had a shorter pipe initially, and well, it seemed like it was a little bit too short for the job. I mean, it is cold out here, but I had to make it a bit longer. Yeah, good thing if there's no snow or ice anywhere over here. Oh, it's so sketchy. This drop is sketchy in the summer. It's like a good 4-foot drop, 5-foot drop. Yeah, I might as well just get down there. Can you hold this though? I'll have you lower it down. That seems like the smarter decision here. This is good. This is nice. If you could, hit that like, comment, and subscribe button, because this one's sketchy. Like, the other ones are kind of sketcy. This one's sketchy. I don't know why I never do this testing when it's warm or anything. All right. Let's go this way for me. The bush, well, the bush has me.
Huh?
The bush has me.
You got it?
Yeah, the person in that truck is like, what the hell?
Yeah, they're just like sitting there.
I would too. I would too. Well, that's an issue.
What?
My pipe is too long.
Uh-oh.
Said me never.
Yeah, right.
Huh?
Yeah, right.
No, seriously.
No,
like,
I know.
Yeah. Damn, I forgot the Sawzall too. Like, don't even have the handsaw. Let me show you the conundrum here. Like I said, for the first time ever, my pipe is too long, and I'm quite upset about it. So I guess we're gonna have to waste 40 minutes, just drive back up, get the Sawzall, come back, cut probably a foot off the pipe. And I'll post more about the flow calculations when I get back up there and I'm not standing on the ledge, but I will update the flow calculations for how much distance I take off. So see you guys in a second. All right, since we have cuts to make and apparently someone's having a picnic exactly where we're testing, and we don't want to litter, we're just going to use our portable work truck. So yep, it's about 10 inches right there, give or take a few sea hairs. I got real scared real quick. What is it hitting? Are you like pushing really hard? Oh, you can't push really hard down. There. That was easy. And made like no mess. And I still have seats. A center console? Imagine I pull the newspaper off and it's like and I have like no vents left. Be hilarious. Should you measure it? Oh, you're dumping. You're making a mess here. Making a mess in the car. That's pretty close. I'll take it. I'll take it. Off by a quarter of an inch for eyeballing it. You measure the other side, it's like a quarter inch over. All right, well, hopefully their picnic has ended so we can go back to testing hydro turbines. Hope you enjoyed this. All right, we are back. My pipe is shortened, and now we are gonna fill this bucket with water. And what we have to do is hold this bucket over the outlet pipe. And this way, when we start the vacuum, it allows there to actually suck the water over the initial little like dam to start the siphon. So once it's started, we can remove this bucket, and we will. But just to get it started, so let's fill our bucket, hang it over the edge, and hopefully start our siphon. Lost our siphon. Oh. Let's try again, but this time I'll try closing the valve down here once it starts. I guess. We're actually losing the siphon when the bucket is lost, and I'm trying to think if that's because maybe there's air getting into the system or something. So just because it's a little bit refined, we're gonna put the camera down, do a little bit more testing, and then I'll get back to you because it's a little complicated. So give me a second here. So what I'm wondering, that's why I didn't bring shears with me, is if there's too much tension on the pulley and the belt, maybe that's why it's causing it not to spin, or maybe that's why it's causing it not to spin as quickly. And we're starting to lose the siphon, where in my small scale testing, when I didn't have the shaft and all the extra stuff going through it, it did hold that siphon even without the bucket. So I want to try and recreate that scenario. So I'm probably gonna change a couple things, but I think what I'm gonna do first is just pop the belt off and try this again, just to eliminate it being that, because I do see air bubbles, so I definitely know there's air in the system. Where it's coming from, I'm not quite sure yet. So I'm gonna keep digging a bit further, and hopefully we'll get some sort of power numbers for you guys. So I'll see you in a second. I think that was actually exactly the problem, because I'm gonna show you how fast and smoothly this thing is operating right now that I took the belt off. It's probably a really dumb idea, but I'm contemplating trying to get that belt on while it's running at full speed. I mean, it's not a huge system, but you sure still wouldn't want to get your finger pinched in there. So I'm gonna debate that decision, and I'll show you guys how it's operating right now. Can you walk my dog? So I don't know if I'm gonna just try this again or throw that belt on, but I don't know. I might try and, I think I have an idea. I think I know how to make this work without getting too much air in the system. So I'm gonna hand this back and let's try something.
Eight.
You got 8 volts?
Yeah, I got up to 8.6.
What's it at? Is it steady?
8.3 right now. It bounces between 8 and 7.
Can I see the camera side? That's one in. Yeah, I'll show you guys. All right, so I think the next steps are, let's move to that 36 tooth pulley and try again. I mean, if it's already having an issue spinning that motor as it is, logic would state it probably won't. But if we switch over to that other pulley, we should get a decent increase in voltage. And then that's probably where we want to be at when we start connecting heaters, but this will change depending on our load. So let's try hooking up that second pulley and see how it does. Might as well while we're here. I want to try one more thing. Before we kill this system, I guess I'm going to take the bucket out. Just keep your eye on that and let's see. I don't know if keeping the bucket under is what's keeping it going or if it's what's limiting the flow of water. So this number might spike in a second or it will probably stop. So.
It hit 8.1.
Huh?
It was at 8.1.
Yeah, it doesn't want to give me the bucket back. Can you hold this rope a second? No.
9. 9. 9.2.
All right, so maybe not our best first test, but also definitely not our worst. While it did make, would you say, about 9 volts?
Yeah.
9 volts. I didn't hook up the power output just because I know this motor, and as soon as you apply a resistance, that would have stopped and cut off the test. So in our first one, we were able to test on the 20 tooth, and the next test I'm hoping we can get to the 36 tooth pulley, thus upping our voltage and starting voltage. So when we drop down, when we apply a load, hopefully we'll still be about 14 volts or so. I think part of the reason why we didn't make as much power as we could have is because maybe some of these different parts in the system were letting in air. Like I don't have pipe tape thread on here, pipe tape thread, but I will get this all taped up next time and silicone the areas where I can't apply that plumber's tape. So I'm gonna go through it, refine it, but I wanna hear what you guys wanna change, what would make this a little bit better. And if you wanna see the internals and the impeller and how I put this all together and why it looks the way it does, well, make sure you check out how I built this turbine.